Wait, this object is called updating copyright?
Yes.
That's silly.
Is this a built-in object?
No. This is something I built.
Wow.
Yeah. So, and I use a lot of sprintf, which basically comes from the programming language C, right?
Yeah.
C uses printf, and it's a really convenient tool to parse variable data in lists, okay? Now this is what I want. If you notice, I'm always going to have copyright Dan Trampty and then the pipe, right? Because that's not going to change every single time. So I could go ahead and prepend the whole thing with copyright Dan Trampty pipe. Cool? So that's not variable, so we don't have to use sprintf in that. But everything, most of the stuff, actually everything after that pipe is something that is variable, right? So that's when I got to start using sprintf. In this case, I'm combining the two lists, the date symbol and the time symbol, and I'm separating it by a pipe. But let's look at how we get the date symbol and the time symbol. Let's go in date time, patcher, let's blow it up. Okay. So basically I have a metronome. Every second it's reporting the date and time. Cool? Now if we look here, we're getting, let me blow it up even more, we're getting strange formats. Like the date format is 11/19 space 2012, which is fine, we all know what that means, but for whatever reason I wanted to say November hyphen 19, you get what I'm saying. And then over here the time format is actually quite strange.
Military time.
First of all, it's military time. Second of all, I mean, yeah, the seconds make sense, but the 4, usually when you see an LED clock, it's got the 00, like 04, and then colons on each side of it, right? So we want to make this formatted in a really nice way, right? So let's go into time. Well, actually, let's show date first.
Do you have this patch on your website?
I will post it on my website. So first, as you noticed, it comes in the date comes in 3 numbers. Month, day, year, right? Where was that? Here. So I'm going to unpack it so that out here it outputs the month, then here, the day, then here, the year. Now, the day and year are going to go straight into the sprint object. Now, the corresponding variables here, percent %LD and percent %LD, that's basically like saying long integer, so whatever integer. It's a little different than like if you were to make an if-then statement or an expression statement that's going to have the $I1. We got used to how that means the integer variable coming in whatever inlet, right? But since we're actually using C language when we're using sprintf, we're using slightly different languages. So instead of, for example, $I2 and $I3, we just have %LD, %LD, and the positioning within the objects corresponds to the inlets that they make. Yeah? %S is going to be our symbol, okay? And that's coming in the first inlet. And what do we have here? We have basically a little patcher that listens to each number. If it's 1, it's January. If it's 2, it's February. And spits out the month in English, not in numbers, right? So we're using month names rather than month numbers. So that's going to generate a symbol. Actually, I could show you what that looks like once that's all done. November M-19 M-2012. So what's really convenient is those M-dashes, you could just kind of type whatever you want in there and it'll spit out through, right? Cool. Now this is very useful because often when you're dealing with lists, especially in Max, everything's separated by spaces. So with this, you can really do whatever you want and not have to worry about the Max format of having a number, space, a letter, space, a word, space, etc. So you can combine everything into a single symbol. Cool. So let's look at how I generate the time. How I get 15, 8, 49, 50, whatever, to look like 3 o'clock, 8 minutes, and 57 seconds. PM, right? So let's open up time. Let me blow it up. Okay. So again, I unpack it. Don't worry about what's going on over here to the right for right now. Okay, so this is actually quite confusing. So the hour is the first one that comes out, right? So I'm taking that hour and putting it over here and over here as well. So when I take it over here, I'm using a split object 11. So this is going to make it so that the first half of the first time around the clock is going to say AM, and then the second half around the clock, when you would get 13 o'clock, 14 o'clock, 15 o'clock, that's going to generate a PM. Cool? And so I pack that into here. The seconds are just going straight into my pack object. The minutes are going straight into my pack object. But what am I doing here on this left side? I'm doing a very similar thing with the split 11, but I'm just saying mod 12, right? So that once we get to the 13 o'clock, 14 o'clock, instead of 13 o'clock, it says 1 o'clock. Instead of 14 o'clock, it says 2 o'clock. Did you have a question? No. And this if-then statement is a little fix for one instance when you have, instead of 12 o'clock, or we want it to say 12 o'clock instead of 0 o'clock. Because when I do that mod 12, when it gets to 12 o'clock, it says 0, right? Cool. And then I pack it all together. The first 3 of those are just numbers. So I just say my arguments are pack 0, 0, 0. And then my last one, which is the AM or PM, since those are, those are kind of words, I am using the argument L for list, so that it takes those, takes the AM and PM as a list. And then I throw it into my sprintf And then I could have thrown each patching cord into the corresponding inlets of sprintf, but instead I'm showing you that you could pack it all together and put it in the first inlet, and it'll all those values will spread across the object and be read this way, right? So then what we're getting is over here where it says %s, that's the symbol, the last symbol in the list, which was my what? AM and PM. Cool. The first thing in the list, the %LD, that was the first number. What was that?
Hour.
Hour. Good. So now the two ones in the middle, %.2D and %.2D, what do those correspond to? Minutes and seconds. Now what is, I'm showing you right here. %2D basically means it's two leading zeros. It's saying if you, for example, if it outputs a 0, it doesn't just say 0, it has 0, 0. Yeah. So you always have kind of like this two-digit thing, at least two digits coming out.
So that way it's like 305, it doesn't say 35.
Exactly, yeah. Cool. So, and that looks like this. 3:13:51 p.m. And that's what time it is, I suppose. All right. And then, so we take those date and time. Oh yeah, I should explain the symbol. So the message is really confusing in how it interprets things like quotation marks. Basically, when you give message a list with all these things, sometimes it truncates stuff. Sometimes, like maybe my colons won't be there when I output out of the sprintf. So when you say sim out, it's basically saying all that stuff after the sim out, keep that, put it in quotation marks, and then everything will interpret it as a symbol. Cool? All right. So I will post that online. I think it's kind of fun, kind of quirky.
Don't steal it, right?
Yeah, seriously, don't steal it. I'll post it online so that you guys can figure out how to work with the sprintf. But do your own thing. And you can't steal it because it's copyrighted.
Right.
Constantly.
Constantly. Every second.
Has nobody made a clock in Max like that before?
Oh yeah, plenty of people do. That's a very common thing. Yeah.
This is yours.
This is mine, and it's an automatic auto copywriter. That's what I wanted. I could have made a clock. That's just one part of it, but I wanted more. Okay, let's not save that. Here's another fun one.
Oh, pretty simple.
Okay.
Figured it out already.
Yeah.
Actually, before we do this, let's just talk about the object, hold on, ZL. Let's give it an argument. Change.
Plus
Okay, so I can bring up the help menu. You will find that ZL can do tons of cool stuff to your lists. Okay? I mean, there are things that it does that make other objects obsolete. So, I mean, it's super useful. Let's look at some of these things. For example, we've talked about the change object, but you can do change with lists, right? So, if I hit A, B, E, C, E, and then I hit it again, it recognizes that it was the same list coming in. So every time I hit it after that, it's saying that it didn't change. But when I do change to over here, this toggle should display an X. Boom. But then when I hit it again, it's not changing. If I go back and forth, it's always changing, but if I repeat, it doesn't. Cool. It's the same concept of just the change object. We can compare lists. So let me get my Max window up. So if I do ABC, if I set ABC in my right inlet and then hit this ABC over here, it says that's the same thing. If I do ABCD, if I set that in my right inlet and then hit the ABC, that's not the same thing. ABCD, ABCD, same thing, displays an X. Cool. Delace. We have A1, B2, E2, C, 5.5, E7. What if I want my numbers over here, my letters over here? You just use delace. And if you look up here, it printed, my delace 2 printed 1, 2, 2, 5.5, 7. My delace 1 printed A, B, E, C, E.
Does that separate numbers from letters, or does it just separate every
Exactly.
other one?
Actually, that's a good question. Let's change it.
Did you mean to put interweave or interleave?
I didn't write this. Interleave.
Okay, what does that mean?
Let's see. Hold on 1 second.
Just where you take
1, 2, ECE. So you're right. It's not putting the numbers here and the letters here. It's putting every other one here and every other one every other one. Yeah, over here. So, and that could be very useful. A lot of these things are very useful for like when you have some kind of MIDI controller that's just spitting a million numbers at you, and you're just like, what do I do with all these? Throw a delace on there, and all of a sudden, oh, I see. It's
Yeah, like if you're getting velocity and pitch
Exactly.
at the same time, then you delace it.
you can delace the velocity and pitch. Okay. ECILS, which is slice backwards, is going to slice the list. Yes, backwards. But depending on how much how many parts of the list you want to slice and put in the front end. So if I change this to 4 and hit the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then if we look up here, it sliced it and put the 7, 8, 9, 10 first, then the 1, 2, 3, 4, 5, 6. Group, I use group a lot, ZL group. Usually when I'm just trying to pair two numbers, if I have a data stream and I just want every 2, so like if it's like A1, B1, C3, D, whatever, I can use group and so that it puts everything into 2s. A1, the next list would be B2 or whatever I forget. I made a weird list to begin with. I don't remember it. But yeah, so it groups. So let's see. but it starts with 4, or the argument is 4. So if I just scroll upwards, you see it counts upwards and breaks it into groupings of 4. We can zoom in there. Little tetrachords. Chromatic tetrachords. Okay, now, I don't think we need to get through all these. Just know that there's a ton of them. I don't remember all of them, but this is only one batch of a bunch. So these are the basic ones. If I go to the next tab, there's 6 more. Next tab, there's 6 more. ZL nth, that displays like the nth number or nth thing in the list. ZL scramble, that takes all the data and randomizes it. ST, there's another 6. Some of them do things like add everything in the list. So I just clicked this 1, 2, 2, 5.75, 75, 777, and I summed them all, 43.5. The sum of 6 plus 1 plus 3 is 10. So you can sum lists. There's actually another one. I think it's ZL median. Where was that? Yeah, down here. This is really useful. So you take the median of all the numbers. 1, 2, 2, 5.5, 7, 5, 7, 7, 7. Median of that is 5.5. The median of 6, 1, and 3 is 3. Good.
Now we can do 6th grade math.
Yeah. We're getting to 6th grade here in Max MSP land. Okay, let's not save. Let's kill that not save. Let's open up a very fun patch I made. So let's go object by object, talk about what's going on. We've seen Metro, what does it do?
Sends out a bang at a certain interval.
Certain interval, I set the argument to 1,000, so
1 second.
every second. Every second, I hit an Uzi 1000. So that's going to bang. That's going to, out the first inlet of Uzi, shoot out 1,000 bangs. That's a lot of bangs. Then, each one of those bangs is going to hit an Uzi 26.
Why?
You'll see. I got a good reason for this. Uzi 26. Then, so each one of those bangs is going to spit out
26 bangs.
26, but in this case, since it's a third outlet, it's what? The index number. So each bang from those 1,000 bangs is going to send out 0 through 25. Okay?
Oh. So you're saying 26,000 bangs per second?
Yes.
That's a
Well,
lot.
20, yeah. But you'll see why I did it in that way
Okay.
soon. I'm going to add 64 to each one of those. Okay?
Okay, hold on. What's the third argument of Uzi?
The third outlet
Outlet.
of Uzi is going to display is going to shoot out the index number. So what's happening is the first Uzi 1000, out the first inlet is going to shoot bang, 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 1,000 bangs. Okay? Each one of these bangs, let's zoom in, is going to hit an Uzi 26, but since it's coming out of the right outlet, it's going to spit out a 0 through 25. So it's going to be, so each one of those bangs is going to generate 0, 1, 2, 3, 4, 5, etc. to 25. Cool?
Mhm.
So instead of sending out 26,000 banks, it's sending out all the numbers. Right.
0 through 26.
Right.
For each one of those 1,000 banks.
Yeah.
There's 26,000.
Yeah, 26,000 total numbers
But
that you'll get. But there's
they only measure 1 through
0 through 25, yeah. So I'm going to add 64 to it. So 64 to each one of those, each one of these. It's an offset, you'll see why pretty soon. Then I'm going to do sprint %C. What is that? No, you're thinking the mod, but since this is sprintf and we're using C language all of a sudden, this %C is going to take those numbers and think of them as ASCII numbers. And it's going to generate the letters that correspond to those ASCII numbers. So you get the ASCII letters. Cool?
Mhm.
Then I'm going to group them together in lists of 26. Okay? And look what we got. The ABCs. I just generated
The
1,000 versions of the ABCs.
Yay.
Okay.
Did you say monkey will drop the F-bomb?
Yes, I did. And I'll get to that soon.
What?
There's something to look forward to. Okay.
Oh my goodness. Teaser.
And then, okay.
Teaser.
So, yeah, that's a teaser. ZL group 26. I put it into a list of 26, A through Z, right? For each one of those alphabets, I scramble them. Okay, so we're generating an alphabet that's totally random. In this case, we got G, F, J, Z, C, P, B, Q, etc. Cool. Not just to show another object real quick. You can use ZL sort and put it all back together again. So sort is really useful because it'll sort things from in numerical order and alphabetical order. I think if you give it like a -1 or a 1 or a 2 or something like that, it will sort in reverse order. So that can be really useful. Okay, but that's just hearsay. Out the scramble, I'm doing a ZL stream 4. So what that means is I'm taking a snapshot of every 4 adjacent nodes, or numbers, or letters in this case. Okay?
Hmm.
So the first one will be, hold up, GFJZ. The second one that will spit out will be FJZC, then JZCP, then ZCPB. Alright, back to where we were. And in this case, I think because it was the last 4 letters, TOWX of the last one, that's what we see. Now I'm taking each one of those letters, TOWX, and using the sprint F and calling each one of these a symbol and not putting a space in between it, I can put it into a 4-letter word so that there's no spaces in between. And you see that right there, TOWX. Now, here's the fun stuff. I'm using sprint F to put together this ASCII word, which you'll have to figure out on your own sometime. Actually, it's the F-bomb.
Yeah.
Because you already know what we're doing, because you saw that. But I didn't want to write it on the screen, so I'm using sprintf to encode it, right?
Oh, you.
So that bangs and it sets the right inlet of compare, and then it drops the list, the random 4-letter word through to the first inlet, and then every time those match, we select one, and then that sends the message to our to our Max window. The monkey typed it. Okay. Now I ran this experiment earlier today. I let it run for half an hour, and I got 116 hits. All right. At 26,000 tests per second. So let's figure out how many seconds are in a half an hour. That's 30 times 60, right? Which is 1,800. 1,800 times 26,000 is 46,800,000 tests that I ran. Okay? So, for me to have gotten 116 out of those 46,800,000 basically means that there's a 0.00000002136,752% chance that a monkey will drop the F-bomb when typing quasi-randomly. I say quasi-randomly because in this situation, well, let me read this. This is only the case if the monkey does not repeat a letter until he or she has finished typing the entire alphabet, which is probably not how monkeys type.
Most monkeys, yeah.
But regardless,
I know a monkey who strictly does that. It's very important.
to figure, so there's, I compared that with how many we should expect to see theoretically, right? Which the equation for that is 1 over 26 times 25 times 24 times 23. It's not just 26 factorial because that would be if the monkey typed the whole alphabet at once, or matched the whole alphabet. But in this case, it's only 4-letter words of those. So that's how many theoretically you would expect to see, which is 0.00. Percent-wise, it's 0.702787. That's what you would expect to see. I got 0.00000002137.
It's pretty close.
Yeah, pretty close.
So your random virtual monkey did eventually type it.
Oh yeah, 116 times. Yeah.
Get rid of the dirty monkey.
Dirty virtual.
He doesn't know what he's doing. Don't blame it on him.
this purpose expressly.
Yeah.
Can you,
So
can you run it?
Max is yes for music, but it's also for silly statistics.
Can we
So-
steal this patch?
Oh yeah, I'll post this patch online.
Can you run this patch really quick?
Yeah, of course.
Sure.
Let's watch. Let me back it out a little bit. Oh, actually, we'll watch the Max window. Yay!
Oh,
Hit
wow.
one.
Whoa, hello.
Wow.
Wow.
Actually, that's pretty quick. Usually,
Your monkey.
Your monkey knows it's
How
out.
many was it per second? That is
26,000
Yeah,
per second.
Now cue the audio file.
I was actually thinking about doing that. A piece based on
Monkey randomness?
monkey, the percentage of monkey, or how often a monkey types dirty words.
I don't know why it has to be a monkey.
You have to do Shakespeare.
If they knew a lot of words, they'd type them all.
Oh, it's got to be a monkey because of the whole Shakespeare thing.
Right, okay.
Yeah. That
When you say monkey, do you mean which monkey?
What type of monkey?
it doesn't matter.
If it's a bonobo, then it will type dirty words
Oh yes.
all the time.
Those the big nose ones?
I did not think. I'm sorry,
I
guys.
think we trained them
Broke
early.
you off in sign
They're
language.
actually like.
So yeah, we got 2 really early on. Now we're waiting.
Very frisky.
Oh, there we go. Yay. Oh,
Whoa,
it's like
what the-
2 at a
wow.
time.
Jeez. I see a pattern here. Whoa, hello. Wow. That's man, this monkey. Can we see the
How so?
The letters go.
Oh, well, it only
Is that against
displays
school policy?
every 1,000th, or
I wonder if the monkeys have STDs.
Oh,
it
there
only
goes one.
displays every, like, 26,000th
Just a monkey.
variation.
So what's
Oh.
the chance that the actual word would be displayed in that box?
A lot less.
At
least.
So we need to. We need
Now,
to
you should have like another connector out of that to display
And then
like,
and then
yeah.
you're just
actually
like,
print
oh
it.
hello.
That can determine the form of the piece.
Yeah, there we go.
What?
Zerzy.
Amy.